In my last video, we have learned the discovery of cathode rays. Today, I am going to discuss the important properties of cathode rays. The important properties of cathode rays were studied by J.J. Thomson based upon certain experiments. Okay. First property, please listen. Already we know when high voltage is applied to cathode and anode, cathode emits some invisible rays. These rays are called cathode rays. Okay. When a solid object is placed on the when a solid object is placed in the path of cathode rays, its shadow can be noticed behind it. Okay, just behind this object we can observe the shadow of that solid object. This shows that cathode rays travel in straight lines. Okay, then the first important property, cathode rays travel in straight lines. Okay. Then we can explain the next property. Please listen here. Okay, if a light paddle wheel, this is a paddle wheel made from mica, mounted on an axis, is placed in the path of cathode rays. This paddle wheel starts rotating. Okay, this paddle wheel will rotate. This shows that cathode rays consist of material particles. Cathode rays consist of material particles. Then please note the property number 2. Cathode rays consist of material particles. Okay. The particles having mass are called material particles. Okay. Then the third property. Okay. When electric field is applied on the cathode rays with the help of a pair of metal plates, here we apply positive field and negative field. Okay. Then these cathode rays are found to be deflected towards positive plate. Okay, the cathode rays get deflected towards positive plate, and it indicates that the particles of cathode rays carry negative charge. Cathode rays consist of negatively charged particles. These negatively charged particles deflected towards positive field when we apply electric field. Yes. The next property. Cathode rays consist of negatively charged particles. Negatively charged particles. Okay. Then the next property, when we apply the magnetic field, we can observe that the cathode rays undergo deflection. Okay. Then we can write the next property. Cathode rays, they get deflected when electric and magnetic fields are applied. Magnetic fields are applied. Okay. Then the next property, okay, please listen here. When cathode rays passes through gases, we can observe that cathode rays ionize the gases. Okay, cathode rays ionize the gas through which they pass. Okay, that means actually we know cathode rays are electrons. These electrons knock out the outermost electron from the gaseous atom, and the gaseous atoms are changed to positively charged ions. Yes. Then the next property, cathode rays can ionize gases. Cathode rays can ionize gases. Then the next property, yes, already we have learned, when cathode rays strike a fluorescent substance like zinc sulfide, they produce fluorescence, that means glow. We can observe glow. Yes. Okay, we can observe glow or fluorescence. Then the next property, they can produce fluorescence. They can produce fluorescence. Okay. Then one more property, the cathode rays can penetrate through thin metallic foil. Okay. These properties of cathode rays show that they consist of material particles, okay, which are negatively charged. Cathode rays consist of material particles, then cathode rays consist of negatively charged particles. These particles are called electrons. Okay, cathode rays consist of electrons. Cathode rays are the flow of electrons. Okay, then in the year 1897, J.J. Thomson for the first time experimentally determined the charge to mass ratio of electron. Charge E, mass M, E by M ratio of electron, and E by M ratio of electron is found to be 1.76 into 10 raised to 8 coulomb per gram. Yes. After that, a famous scientist, Mr. Millikan, found the charge on electron by oil drop method, and the charge of electron is 1.602 into 10 raised to minus 19 coulomb. Then mass of electron. Yes, then how can we calculate mass of electron? M. Mass of electron M is equal to E divided by E by M. Am I right? Yes, E divided by E by M means what? E into M by E, E cancels. You will get M. That means the value of E charge on electron is 1.602 into 10 raised to minus 19 coulomb, and the E by M of electron is 1.76 into 10 raised to 8 coulomb gram inverse. Then after solving, you will get the value 9.1 into 10 raised to minus 28 gram, that is equal to 9.1 into 10 raised to minus 31 kilogram. Okay? So, E by M electron is 1.76 into 10 raised to 8 coulomb per gram. Charge on electron E is 1.602 into 10 raised to minus 19 coulomb, and the mass of electron is 9.1 into 10 raised to minus 31 kilogram. Thus we can say that electron is a fundamental particle which carries 1 unit negative charge. Okay? Charge, the magnitude of the charge is 1.602 into 10 raised to minus 19 coulomb, and the negligible mass of electron is 9.1 into 10 raised to minus 31 kilogram. Okay? In my next video, I will discuss discovery of protons. Okay, students, goodbye, study well.